Hello, this video is discussing section 2.7, measuring the spread of our data. And for this, we're going to be talking about something called variation and standard deviation. So there we go, range, variance, and standard deviation. So, this is mainly going to be discussing how far data values are from the mean. And the standard deviation is the number that tells us how far our data values are from the mean and how far spread out our data is from the mean. And it provides the measure of the overall variation. So the standard deviation and the variation are pretty synonymous. In fact, to find the standard deviation, you just take the square root of the variation. So they're really linked well to each other. Standard deviation is a number that's always going to be positive, or it could be zero. It's small when the data is closely concentrated closer towards the center or the average, exhibiting little variation or spread, and the standard deviation is larger when the data values are more spread out. So we're going to use this to determine whether our data values are close to or far from the mean. Something that's 2 standard deviations from the average is just on the borderline for what many statisticians would consider to be far from the average. And if you're too far from the mean, if it's more than 2 standard deviations away from the mean, it's going to be approximate rule of thumb than a rigid rule. We'll talk more about that in the future. So that's a way to calculate outliers and things like that. And the shape of our distribution affects how much of our data is further away from 2 standard deviations. So we're going to talk more about the shape of the distribution in a little bit. Calculating the standard deviation is a really pretty difficult task. We'll get to that in the next slides. We have 2 different symbols here. Lowercase letter s represents the sample standard deviation. Sample meaning it comes from a small subgroup from the total population. The Greek letter sigma, and lowercase sigma, represents the population standard deviation. So these are very similar, but the calculations are a little bit different. We use the population standard deviation when we know everything in the entire group, like a softball team. If we know everybody on that team, we would use the population standard deviation. If we're looking at a whole city and we only use one small part of the city, that's a sample. So we use, obviously, the sample standard deviation. Okay. Next slide. So to calculate the standard deviation, we calculate the variance. And here it's kind of talking about how to calculate this. And I think it's best shown on the next page. So I'll skip ahead there. Well, what we do, I guess, it's the average of the squares of the deviations. A deviation is how far something is away from the average. So we take that and we calculate. Let me just go to the next page, actually. So there are the formulas. They look complicated, but I'll go to the next page here. So here we have some data. 20 people, 5th graders, their ages are here. So what we do is we take all of these ages, and we notice we have some multiples here. So they made a frequency table. So the 11 shows up 6 times. So they put 11 and 6 for the frequency. First thing you need to do is calculate the average. Luckily, our programs will calculate all of this for us. So we really don't need to get too bogged down with making all of this. We're not going to slog through that really at all. But it's good to see where it comes from. So the average age is 10.53. So the first thing we need to do is calculate the deviation, the distance from that age. So the first one would be age 9 compared to the average. And 9 is about 1.53 years under that. So what we do is we take 9, we subtract. On here it looks like the actual average was 10.525. They must have rounded this one a little bit. So the deviation is the distance from the average. So that's 1.525 years under the average. So that's why it's a negative there. So for all of our other ones, we just calculate that distance from the average. Here, 11.5, that's about a year above the average. Then we take all those deviations and we square them. Squaring them just gets rid of the negatives. and it makes them bigger too, or generally, but it's not necessarily bigger, but it just squares them. We'll end up doing the square root at the end to get rid of that. So we square them, and then we go ahead and we add up all of these deviations squared. Since we had 11 of these or 6 of these values at 11, that's why we multiply this one by 6. We just multiply it by the frequency because there would have been 6 of these values out there. Then we add up all those values, and my little box is in the way. So there we go. We get 9.7375. So then we take that. I'll go back to our formula here. We just did the differences or the deviations squared, and we summed them. Now we have to do the divide by part and then the square root. So we divide by the number of values, 20 minus 1, so 19. We get this number. So that's called our variance. Then to find the sample standard deviation, we take that number and we take the square root of it. And there it is. So our sample standard deviation, the number we're looking for is 0.72 for this data set. So it's a pretty small number because these ages are pretty well clustered together. All right, so I know that was a lot. We kind of went over this quickly, but the exact formula we're not really necessarily going to have to calculate by hand. So here we're going to now use the calculator or computer software to calculate our standard deviation. And I'm going to go to Google Sheets. And I'm going to take my data, and I'm just going to make up some random data here, just so you can see how to do this. So remember to calculate our values, like to find the mean, we hit equals average, and we type in, go to that column. To find the mode equals mode, and we go to that column. This time we want the, oops, oh, why is that not wanting to work for me? Equals, oh, there is no mode. We would just say no mode because no number occurs most common or most often. But we're not worried about that. We're worried about standard deviations. So we have two types of standard deviations. We have the sample standard deviation and the population. The most common is the sample standard deviation. And so in fact, if you type in equals standard deviation, it's going to default to giving you the sample standard deviation. The population standard deviation is a little different to get to. You type in this STDEV for standard deviation, and then the .P1 stands for the population. So if we knew this was the whole group, we could use that one. And here I'll show you how to get the other one. Sample standard deviation is with the .S. And that is that one right there. So there we go. We can see the other. Oh, there's one of the entire population too. So two different ways to do it. Okay. Text as 0. So that's using some text in there. We don't need that one. All right. So that is how we use Google Sheets to calculate our standard deviations. And it's pretty slick. So we can go back to this one, talk a little bit more, and then I'll make a new video for the next part. So now we know how to calculate it. And then the other part is if we have, just like in our other one for the average, if we have a range of values, what we would need to do is find the midpoint for each of these. So we would use 1, and here we would use, 4? Here we would use 7. So we find the average of these numbers, and then we would list out our data. Okay, So the next part is comparing values from different data sets, and I will make a different video on that one.